So, you're an aspiring machine learning engineer and you're aiming for the top, a senior, or even a lead role. You've probably realized the path to get there isn't exactly a straight line. Well, today, we're changing that. We are laying out the complete strategic blueprint based on some deep industry analysis that shows you exactly how to become one of the most sought-after engineers in tech. Let's just dive right in. Right now, the entire AI industry is up against a huge problem, and it really all boils down to this one number. Get this. While pretty much every major company is throwing money at AI, only a tiny 1%, just one, considers themselves mature when it comes to actually deploying it. This isn't a tech problem, it's an execution problem, and that is exactly where you come in. So, here's the bottom line. The modern ML engineer isn't just a model builder anymore. No way. You are the essential bridge builder who's going to close that massive gap between 1% and everyone else. You're the one who connects the dots between theoretical research and the reality of scaled, production-level systems that actually deliver value. And that, right there, is why these engineers are in such insane demand. So in this explainer, we're going to walk through the 6 critical phases of this career roadmap. We'll start with the new mandate for ML, then talk about shifting your mindset from models to systems. We'll cover the MLOps revolution, that big jump to leadership, how to architect for massive scale, and finally, how to carve out your own strategic advantage. All right, first up, the new ML mandate. The stakes have never been higher, which honestly just means the opportunity has never been bigger. Check this out. McKinsey estimates that generative AI just by itself represents a $4.4 trillion opportunity in added productivity. But here's the catch. All that value stays locked up unless there are engineers who can take these incredible models out of the lab and actually make them work in distributed, real-world environments. This is the new economic engine, and it's driving all the demand. Okay, so to really seize this opportunity, you've got to make a fundamental shift in your mindset. It's time to stop thinking about isolated models and start engineering end-to-end systems. This comparison really gets to the heart of it. Academic ML, this stuff that usually lives in a notebook, is all about model accuracy in a nice, clean, controlled world. But production ML, that is a completely different ballgame. It's about engineering systems that are reliable, scalable, and fully integrated. Systems that have to perform flawlessly out there in the wild. But, and this is important, you can't build those systems without a rock-solid grasp of the theory. A deep, intuitive understanding of these statistical foundations is your superpower. It's what lets you debug a complex production system when things inevitably go wrong. It's the difference between just knowing how to call a function in a library and truly knowing why an algorithm actually works. And that practical application of theory brings us right to what is probably the single most important competency for scaling AI today, the MLOps revolution. This is the engine room. This is the set of practices that finally solves the industry's big deployment problem. Simply put, MLOps takes all those proven principles from DevOps, things like CI/CD, and applies them directly to machine learning. It's the discipline of creating a process that is automated, repeatable, and totally reliable for the whole lifecycle, from getting the data to training to deployment and all the way to monitoring. It's basically the factory floor for AI. It's how you go from making one-off artisanal models to industrial-scale production. Now, most companies have to climb this MLOps maturity ladder step by step. A lot of them are starting at level 0, which is just pure chaos, right? It's manual handoffs, scripts getting thrown over the wall from a data scientist to an engineer. There's zero repeatability. Level 1 is a big step up. That's where you start to automate the training pipeline so models can be retrained on new data systematically. But the real goal, the North Star, is level 2. This is a fully automated CI/CD pipeline where deploying a new model is as fast, as reliable, and as boring as deploying any other piece of software. Now, one of the most critical pieces of architecture for getting to that level 2 maturity is something called the feature store. The best way to think about it is as a central, single source of truth for every single data feature your models are using. It's a special kind of data system that's built just for machine learning. And here's why that's such a big deal. The feature store solves one of the most common and most expensive failures in production ML. It's called training serving skew. This is the absolute nightmare scenario where the features you use to train your model offline are even subtly different from the features it sees in the live, online world. A feature store forces that consistency, making your production models way more reliable. Okay, so once you've truly mastered the technical systems, the next step in your career is a really profound shift. It's all about moving from being a top-notch individual contributor to becoming a true force multiplier for your entire team.
I love this analogy because it just captures the whole thing perfectly. See, becoming a lead isn't about just being a faster, better senior engineer. That's just a faster car. It's about changing the very nature of your work to provide a totally different kind of value, like an airplane. You're not just moving yourself forward anymore, you're listing up the whole team. So, how do you become that airplane? You scale yourself. You start building tools and frameworks that make everyone else on your team more productive. You share what you know in a way that turns 1 hour of your learning into hundreds of hours saved for the team. You stop owning just your little component and you start owning the end-to-end system, multiplying your impact at every single step. And this leadership mindset gets tested directly in the one interview that's the gateway to all senior roles, the system design interview. This is where you have to prove you can architect the kind of massive, real-time systems that power big tech. And the good news is you don't have to wing it. There's a proven, structured framework for this. You always start by asking a ton of questions to really understand the requirements. Then you sketch out a high-level design. Next, you drill down into the most critical components. And finally, you bring it all back together, talking about potential bottlenecks and how you'd monitor the system in production. And we see this framework in action all over the real world. For a system like Uber's ETA prediction, the main challenge is real-time, super low latency. So the architecture just has to rely on things like event streams with Kafka and high-speed caching with Redis. For Netflix, the challenge is insane scale and availability, which they solve with a microservices architecture and tons of charted caching. See, these aren't just random lists of technologies. They're architectural patterns designed to solve specific, high-stakes business problems. And finally, to get to that absolute top tier, you need to cultivate a strategic advantage. You do that through deep specialization and by finding the leadership archetype that fits you best. Right now, one of the highest impact areas you can specialize in is generative AI efficiency. This means you have to master something called parameter efficient fine-tuning, or PEFT. And the one technique you absolutely have to know is Q-LoRa. It's a total game changer. It combines the LoRa method, which trains these little adapter layers, with a super powerful technique called quantization. Quantization basically just reduces the precision of the model's numbers. You can think of it like using fewer decimal places. This shrinks the model's memory needs like crazy, which makes it possible to fine-tune massive language models on hardware that's actually affordable and accessible. Mastering this one skill is a massive career advantage. As you grow, you'll probably find yourself evolving into one of these three leadership archetypes. The tech lead is all about team execution. The solver is the one who goes after the riskiest, most complex problems. But the ultimate goal, the role that has the biggest possible impact on an organization, is the architect. And really, this is the final, most crucial takeaway. The whole journey leads to this point. You transition from being someone who just builds things to being the person who defines how things are built. As an architect, you're the one setting the standards for critical infrastructure, like feature stores and model deployment. And in doing so, you scale the impact of every single ML engineer in your entire organization. So there you have it. We've laid out the complete strategic roadmap, all the way from foundational theory to architectural leadership. The blueprint is now in your hands. So the only question left is, what are you going to build first?